Differential equations. Solve the differential equation d cube minus 3d plus 2 into y is equal to x. Now this differential equation, the solution has two parts. Y is equal to complementary function plus the particular integral. So first let us find out the complementary function, and this can be done by equating this part of the differential equation to 0. That is d cube minus 3d square plus 2 is equal to 0. And we get three factors, d minus 1 into d minus 1 into d plus 2 is equal to 0. So the roots of this differential equation are d is equal to 1, comma 1, comma minus 2. So this has three rational roots and two of them are repeated and one is a non-repeat. So the complementary function will be c1 plus c2x into e raised to x plus c3 into e raised to minus 2x. Now to find out the particular integral. Now this given differential equation is of the general form f of d into y is equal to x raised to m, where m is any positive integer. So the particular integral of this type of differential equation will be pi is equal to 1 upon fd into x raised to m. So comparing this general form with this equation, f of d is d cube minus 3d plus 2 and x raised to m is x, that is x raised to 1. So pi would be 1 upon d cube minus 3d plus 2 into x. Now this f of d, you have to express it in the form of 1 plus phi of d, that is 1 plus some function of d. So let us express this d cube minus 3d plus 2 in the 1 plus phi of d form. So we can write here d cube minus 3d plus 2. Now you want a 1 here, so we'll have to reverse this. 2 minus 3d plus d cube. So we reverse the order of this particular expression, and to get a 1 here, we'll have to divide and multiply by 2. So this will be 2 into bracket 2 minus 3d plus d cube upon 2. So now here we can pull out the minus common. So this will be 2 into bracket 2 minus 3d minus d cube upon 2. So this will be 2 into bracket 2 by 2 minus 3d minus d cube upon 2. This will cancel as 1. So this will be 2 into bracket 1 minus 3d minus d cube upon 2. Now you can see this is of the form 1 plus phi of d. That is 1, and this portion is the phi of d. So now we rewrite this as pi is equal to 1 upon 2 into 1 minus 3d minus d cube upon 2 into x. Now we bring this up here. So this would be 1 upon 2 into 1 minus 3d minus d cube upon 2 raised to minus 1 into x. Now we have to expand this using this particular expansion. 1 minus bracket raised to minus 1 is 1 plus bracket square plus bracket cube and so on. So this bracket is 3d minus d cube upon 2. So this expansion would be pi is equal to 1 upon 2 into 1 plus 3d minus d cube upon 2 plus 3d minus d cube upon 2 the whole square into x. Now we neglect the higher powers. So here this would be 1 upon 2 into bracket 1 plus 3d by 2 minus d cube by 2 plus, let us expand this. This would be a minus b the whole square. This would be 9d square minus 2ab, that would be minus 6d raised to 4, and the last term would be b square, that would be plus d raised to 6 upon 2 square is 4 into x. Now if you see here, d is the differential. This is the first order derivative, third order derivative, second order derivative. But if you see, the derivative of first order derivative of x is 1, second order is 0. So we will only need d here. D square, d cube, d square, d raised to 4, all would make this 0. So we can neglect all these terms. Minus d cube by 2, 9d square by 4, this all terms can be neglected. We will only keep these two terms. So pi would be 1 upon 2 into bracket 1 plus 3 by 2d into x. So now we can open up the bracket. This would be pi is equal to 1 upon 2 into x plus 3 by 2 d into x. So this pi would be 1 upon 2 into x plus d of x, means the first order derivative of x is 1. So this would be x plus 3 by 2 into 1. So pi would be 1 upon 2 into x plus 3 by 2. So this is the pi. The complete solution is y is equal to cf plus pi. So y is equal to cf is here c1 plus c2x into e raised to x plus c3 into e raised to minus 2x, and pi is plus 1 by 2 x plus 3 by 2, which is the complete solution. Thank you very much.